In this video, we're going to talk about how to solve problems involving direct variation. So direct variation happens when the relationship between x and y can be described by the equation y equals kx, where k is a number called the constant of variation. So when we work on these problems, you'll see that the k is replaced by a number that tells us the constant of variation. It is also said that y varies directly with x if this relation is true. So this phrase is going to be very important to us when we work on solving these problems. So what does direct variation look like? All of these equations on the left are examples of direct variation. Notice that they all have the format y equals kx, where k is replaced by a number. These examples are not direct variation. Y equals 3x plus 3 is not direct variation because there's a plus 3 at the end. Y equals -2 and x equals 5 are not direct variation because it doesn't tell you the relationship between two different variables. So let's try some problems. If y varies directly with x and y equals 85 when x equals 5, find the value of k. So this phrase right here, this y varies directly with x, is super important when we're solving these problems. So anytime you see that, that means we're going to be using the equation y equals kx. So we need to find the value of k, so we have y equals kx. We're given a value of y and we're given a value of x. We can use those to solve for k. All we need to do is plug those given values into this equation. So instead of y, I'm going to write 85, and that equals k times x, which is 5. Now I need to solve this equation for k. Remember that to solve equations, we need to use our opposite operations. So here I have k times 5, so I'm going to undo that by dividing both sides by 5. So when I divide both sides by 5, on the left side I get 85 divided by 5, which is 17. And that equals, on the right side, 5 and 5 will cancel, so I have 17 equals k. So that is my constant of variation. And remember, I can use that to write this equation. This direct variation relationship can be modeled by the equation y equals 17x. So let's try this problem. If y varies directly with x and y equals 21 when x equals 3, find the value of k. So once again, we have this very important phrase, y varies directly with x. So that means that y equals kx. So we have y equals kx. We're given a value of y, given a value of x, need to find k. So I'm going to plug in 21 for y, and that equals k times x, and x is 3. Now to solve for k, I need to do the opposite and divide both sides by 3. So I'm going to divide this side by 3, and I'm going to divide the left by 3. 21 divided by 3 is 7, and that equals k, because 3 divided by 3 will cancel. So 7 is my constant of variation, so my equation will be y equals 7x. So now in this problem, it tells us that suppose y varies directly as x and y equals 36 when x equals 4. Find the value of y when x equals 11. So let's think about what we have here. We're once again told that y varies directly as x. So that is our important phrase that tells us we're going to be using y equals kx. It gives us a set of conditions. It says y equals 36 when x equals 4. Okay. Then it says find the value of y when x equals 11. Well, I only have y equals kx right now, right? If I want to find a value of y, what I really need is I need to figure out the value of k. So what I'm going to do is I'm going to use this first set of conditions, this y equals 36 when x equals 4, to figure out the value of k. So what I can do is I can plug into this equation and I get 36 equals k times 4. So notice that this equation I can actually solve to figure out the value of k. I'm going to divide both sides by 4, and I get 36 over 4, which is 9, equals k. So that means I can write my direct variation equation as y equals 9x. So now that I have y equals 9x, I can use that to figure out this part, the value of y when x equals 11. So I can go to this equation and plug in x equals 11. So I have y equals 9 times 11. So that means that y equals 9 times 11, which is 99. And that is my final answer. So let's try this problem. Suppose that y varies directly as x, and that y equals 72 when x equals 6. Find the value of x when y equals 36. So once again, I have my y equals kx situation, but I need to figure out the value of k in order to be able to find this value of x. So I'm going to use this set of terms right here, this y equals 72 and x equals 6, in order to figure out the value of k. So if I plug in, I get 72 equals k times 6. So I can solve this equation now by dividing both sides by 6, and I get 72 divided by 6, which is 12, and I have 12 equals k. So now I can use this 12 equals k to write the equation y equals 12x. So I have y equals 12x. I can use this to find the value of x when y equals 36. I'm going to go to this equation, plug in 36, and I have 36 equals 12x. I can use this equation now to solve for x by dividing both sides by 12. 36 divided by 12 is going to be 3, and I have 3 equals x, which is my final answer. So in summary, remember that if a variable y varies directly with another variable x, they will have the relationship y equals kx for all values of x and y, where k is a number. You can use this equation to solve problems involving direct variation.